Hello, we're going to have a look at irrational numbers now. So irrational means not rational, just like irregular would mean not regular. The I stands for not rational. So that means that we are dealing with not rational numbers. So Q is our letter for the set of rational numbers, or is the name for the set of real numbers, all the numbers we've dealt with up until now. So we're dealing with real numbers that are not rational. So irrational numbers. That would be the set notation way of writing out irrational numbers. And the formal definition would be some number which is not equal to a over b, where a and b are elements of z, are integers, and b is not equal to 0. So b cannot be equal to 0 because we can't divide by 0. Now we've come across, or we can come across the idea of irrationality in proofs, where we would be looking at the proof by contradiction that root 2 is not rational, is an irrational number. So we can see it in that part of our course. And just a reminder, I mentioned set notation to begin with, and we have our different sets here, and reminder that natural numbers are a subset of integers, are a subset of rational numbers, are a subset of real numbers. We haven't come to this yet, but I've drawn it in just for completeness. This is going to be our topic fairly soon. Complex numbers are numbers that involve this letter I. We don't know much about that yet, but we will. So far, this circle here, this set here, is the real numbers. This is all of the numbers we have ever dealt with in maths up until this point. And very soon we will be dealing with the larger set of complex numbers. So to say it at the outset, real numbers will be a subset of complex numbers. So it's important to have that idea in our heads that natural numbers are a subset of integers, and so on out the way. They could ask us a sets type question, a more abstracted sets type question, where they asked us to get the relationship between our different number groups, and we have to recognize what set is a subset of other ones. So the natural numbers would be a subset of the integers, and so on. So n would be a subset of z. Now, what styles of, we're dealing with irrationals now, so what styles of irrational numbers have we come across before? Well, the most common one we deal with is surds, and we would also have numbers like pi and e for exponentials. They would be numbers that can't be written as fractions. And we're going to have a look at some surds because, as I say, they're quite a common way that we can come across irrational numbers. We can't write a surd as a fraction. So if they ask us a question like this, where we have a bunch of stuff underneath square roots, and we're asked to write it in the form a times root b, that indicates to us that all of these have the same, can be broken up into the same surd. So the fact that I've got a root 2 here tells me that I am dealing with a situation where both of these can be written as some number multiplied by 2. So if we get a surds type question like this is effectively just an algebra question. We are going to look for perfect squares that we can multiply by to get some perfect square multiplied by some number that ain't a perfect square. So let's have a look here. If we have 32, can we write that as anything multiplied by a perfect square? And we can. We can write that as 2 multiplied by 16. So this is going to be the game. You can cheat at this a little bit and figure out what the answer should be using your calculator. If you put in root 32 into your calculator, you will get out the final answer, which in this case is going to be 4 root 2. But you need to be able to use that to show these intermediate steps. If you just write down 4 root 2, or if you just write down a final answer, you will lose massive marks or may not get any marks at all. So it's important, if we're using the calculator to guide us, that we're still able to get back to this situation here and be able to write it down. Because if they ask us to do this, the point is that you can break up the number into perfect squares and non-perfect squares like I've done here. So I've broken up 32 into 16 by 2, and the reason for that will become apparent in just a moment. And 72, we have to think through, just start trying to multiply perfect squares by 2 and see what number you run into. In this case, it's 36. So it would be 36 by 2 would give us 72. And then we just have the root 2, which is fine. Don't need to do anything with that. There's no perfect square that we can deal with. Now, why did we bother doing this? It's because I can break up square roots, stuff that's underneath a square root, into the product of square roots. Both of these things are to the power of a half, so I can break that up. I can put the power of a half on one of them and power of a half on the other. That should be a root 2. What does that allow me to do? Well, because I broke this up into a perfect square, square root of 16 is just 4. So that's 4 root 2 plus 6 root 2 plus 1 root 2. So in total, I have 4 and 6 and 1 is 11 root 2s. You can see that the root 2 almost acts like a letter in algebra. We just count up how many root 2s we've got in total. So now we have it in the form we were asked for. A and B are integers. So that is how we break these questions down. Try and break up your numbers underneath the square roots into perfect squares times whatever is left over. And that will pretty much always get you to where you need to go. But if we don't write these intermediate steps in, we are going to either get no marks or very few marks. So this is non-optional. We must break it up into these steps to demonstrate that we know how to break up our surds, because that's really what they're asking us. They're not asking us, can we sub something into a calculator? So it's important in these type of questions where we're not dealing with algebra to emphasize that this part here is really the question. Can I get to this stage is what they're most interested in. Not can I put this into the calculator and get that answer out. So the last thing we can be asked in connection to this is how we can construct square roots of numbers, root 2 or root 3 or root 5. And the way that we're going to do this, as we often do with a construction, is to draw a sketch. And the sketch we're going to draw is of a right angle triangle. We're effectively going to use Pythagoras, h squared is equal to a squared plus b squared, to form whatever number they have asked us about. So how would I form root 3? Well, this will just require a little bit of experimentation and thinking through. They will almost certainly give you a bit of guidance in the exam. But if we had 2 squared would be equal to 1 squared plus 3 squared. Sorry, root 3 squared. So we would have 2 squared is equal to 1 squared plus root 3 squared. So we'd end up with 4 is equal to 1 plus 3, which is true. So we need to construct a right angle triangle with a hypotenuse of 2, one side of 1 and the other side of root 3. And this is one of our standard triangles that we'll know from trigonometry. So we draw in our sketch, we use our Pythagoras to figure out what our triple needs to be, what the sides of our triangle need to be in order to end up with our square root that we want. And then we need to figure out how to construct this triangle. So the first thing we need to do is create our right angle. So for Pythagoras, we need to have a right angle triangle. So we effectively just need to get perpendicular lines, and then we're just going to count out the numbers that are whole numbers on our construction. So I'm going to draw in a line segment, and then we'll look at how to get its perpendicular line through it. So what I've done is just draw a straight line. I'm allowed to use a straight edge, so I can draw a straight line, and I pick a point. It does not actually matter where. I pick a point on A. Sorry, I pick a point on my line, and I've labeled it A. Now I'm going to put in another point, B, and I need to get my right angle. That's my first job. So what I'm going to do is get the perpendicular bisector of AB. To get my perpendicular bisector, I open up my compass. I put the sharp point of the compass at A, and I go more than halfway, comfortably more than halfway from A to B, and then I go up and draw an arc roughly above where I think the center is. Then I keep my compass at the same size, put the pointy bit at B, and draw an arc and an arc. And where they cross each other is the line through where they cross each other is going to give me the midpoint of AB, and it's also going to give me a perpendicular line through AB. So this is how we construct the perpendicular bisector of AB, and this again gives us our right angle. That's really all we're after at the moment. Now, I've drawn this in. This is my perpendicular lines here. This is that corner of my triangle. So I'm going to draw my triangle in here. What remains to me is to be able to figure out these lengths here. So the one is fairly easy. I can open my compass up to whatever length I like, and now that becomes my 1 unit. So in principle, they shouldn't be able to take marks away from you for actually using a centimeter or something like that that you're comfortable with, so long as it's clear from you using the arcs on your compass that you are using your compass to get the lengths and not a ruler. These construction marks are what you get marks for in a construction. It is not that you end up with something wildly accurate. You do have to be accurate, but the marks are for the arcs and the drawings, the construction lines that demonstrate that you know how to construct something, not that you can use your ruler to measure out the lengths. So you can use your ruler or opening your compass up to a measurement you're comfortable with, but you don't technically need to. You can open it up to whatever is a convenient length and draw in your arc, and that's going to be your length of 1 unit. So I have drawn in my arc of basically an arbitrary length, and this is now the corner of my piece. So you may as well label some of these things. I'll call that C because I made that at before, and then D. So this is C and then D. Now I need to figure out A, B, C, D, E. I need to figure out where E should be up on this line. That's what I'm missing. So I need to figure out where E should be. I now know D is going to be 1 unit, and E should be on this line 2 units away from D. So what I'm going to do is use this line as effectively my gauge, as my ruler, and I'm going to mark out 2 distances, 2 of these distances away from D. So I keep my compass the same size, I go to C, and I make another arc of the same length, and then from D out to my second mark is going to be 2 units away from D. So I now have my mark. I have gone this length and then this length again. So this is 2 units. This mark is 2 units away from D. If I open my compass now up from D to this mark and draw an arc in at that length, I will get a point on this line that is 2 units away from D. So I now have my arc that was 2 units away from D here. So if I continue that arc up to where it crosses my perpendicular line, I now must be at my point E. So that has to be the point E. So if I draw in a line now from D to E, that point there, that distance must be 2. This distance is 1 unit. Therefore, this distance here must be √3. So here I have labeled in my different sides of my triangle. And again, my sketch from Pythagoras is what gives me the rough notion as to what I need to do. I then must construct my perpendicular lines, my right angle for my triangle, and then open my compass up to a particular length. And I can use AB to measure out however many units I need to go up, either here or in other triangles, I'd be going straight up from my point C. The key thing is this is how we do write out all of our construction lines to get our full marks.